Okay, this is going to cover number 10 on the Unit 2 concept list. This is dealing with our 6.3 unit in the book. Basically, it's our business applications. So first part here it says, suppose 100,000 lamps are to be produced in a year. It costs $1 to store a lamp for a year and $500 to set up the factory to produce a batch of lamps. Find the number of lamps to produce in each batch to minimize the total cost. Okay, so this is one of those formulas where I'm going to provide it for you. You just have to understand what all the pieces represent. So this Q got covered up. But this is our quantity that we should order is equal to the square root 2FM over K. F is your fixed cost, remember. M is your total units for the whole year. And K is your cost of storing 1 unit for 1 year. And so we just have to find each of these variables and determine what we're solving for here. So Q, F, M, K. So I'll give you the formula. You got to know what they mean. So Q, remember, is our quantity. That's what we're trying to find, the number of lamps. But it tells us that the fixed cost here was the 500 setup. It told us that the total units we need were 100,000. And our price per unit for 1 year was that $1. And then we're solving for our Q. We can go ahead and set it up. 2 goes first, then our F value of 500, then our M value, that big 100,000. And then we're going to divide by 1. What I'm going to recommend when you type this in is don't do the square root to begin with. Just do the stuff inside. So that would look like 2 times 500 times the 100,000. Okay, then divided by your 1. Since it's all multiplication and division, you don't need extra parentheses because order of operations, those all go in the same part. Then we take the square root of that number. And it's our 10,000. Okay. Next one, it says for the demand function. Oh, that's actually C. I didn't change these around. Okay, so for part B, for the demand function, okay, quantity is 48,000 minus 10, the price squared. We want to find Q where the revenue is maximized. So first of all, we have to understand that revenue is quantity times price. Okay, so we'll go ahead and set that up here. Our quantity was given to us by our demand function. And then we're multiplying it by the price. Remember, maximize, minimize, those are things that mean first derivative. So I like to simplify. Before we do that, we'll distribute P through. So our revenue is 48,000 P minus 10P cubed, and then we got to find the derivative of that. So first part, just 48,000, the P goes away. And then here we've got minus 30. Power rule makes that go to squared. And we're just setting that equal to 0. Okay, I like to add over this part. Since it was already negative, that way I don't have double negatives. So 30P squared equals 48,000. Okay, we're dividing by 30. So P squared equals, that's 1,600. The square root of this could be plus or minus 40, but because we're talking about the price, we're not going to charge negative, so it's just 40. So $40 was the price that we're going with, but it says find the value of Q, so now we just have to substitute that in the original. So 48,000 minus 10 times 40 squared. Okay, we just had the 40 squared was 1,600. So it's 48,000 minus 10 times that would be 16,000. And then that's your 32,000. Open, that's quantity, not price. So that would be your units of whatever you were working with, selling. Okay. Okay, to backtrack to that last one here for part C. This one, it says, here's our demand function, and we want to know, is it elastic or inelastic when P is $100? Okay, I will give you the elasticity of demand formula. Okay, so let's go find E. You have to know elasticity, whether less than 1, greater than 1, inelastic or elastic. Okay, so when we're looking here, we want to determine first by substituting in. We were given P equals 100. So first thing is we know P is 100, and we're going to plug in to find Q. So 300 minus 2 times 100. That gives you 300 minus 200 is 100. Okay, so we've got both of those, and now we're subbing in our formula. E is negative P, so that's negative 100, over Q, that was 100, and then times, this is the derivative of Q with respect to P. So here's our formula. We need to find our derivative. So 300 goes away. Negative 2 is just our constant, so that's it for that one. And then we simplify. This first part is negative 1 times negative 2 gives us E is positive 2. And if that value is greater than 1, we're elastic. That's it on that one.